We are in the fourth unit of semantic parsing. So we are looking at a predicate argument structure and its role for semantic parsing. In the previous unit, in the same chapter of semantic parsing, we have seen word sense disambiguation. So we have seen what are the resources for word sense disambiguation. Primarily, we discussed about WordNet, which is the database of the words and their senses. Then we talked about the systems used, rule-based systems. There we have seen LESC algorithm, then SSI algorithm. Then in supervised and unsupervised algorithms, we have seen Yarosky's algorithm. Then multilingual context, we have seen Salam algorithm. Then we have seen Mihelshia algorithm. So with that background, we have moved into predicate argument structure. And in the first lecture, we have seen the resources. Primarily, we have seen two resources. One is known as FrameNet, another is PropBank. In FrameNet, every predicate will instantiate a certain frame. So that frame will contain all the context and the words. And whereas PropBank FrameNet contains frame elements, and there we talked about lexical unit. Then in the PropBank, every predicate is stored or referred, explained with arguments from argument 0 to argument 5. Argument 0 is the subject and argument 1 is the object, and we have seen how those arguments are useful in analyzing the semantic role labeling. So I hope you remember that semantic parsing, another name for that is semantic role labeling. So we talked about FrameNet as well as the PropBank, and Frame is a conceptual framework. PropBank has arguments to assign the specific roles. But the problem with FrameNet and PropBank is that they require huge amount of manual effort to create the frame sets for all the predicates or the verbs. And for any language, there are numerous predicates exist in any language, and every verb will not have a single meaning. It is polysemous. It will have different meanings in different context. So creating all the frames for all the verbs, and in NLP we are not talking about one language. We are talking about all the natural languages. So this is very time consuming and very cumbersome task. So what are the solutions for that is whether we can approach this problem with supervised learning. What is supervised learning? You have labeled data. In NLP context, we have human annotated data. And this human annotated data, if we have sufficient amount of data, we can train a classifier, or we can train a system, and we can use that system to test the new senses or new semantic role labeling. So Green, Dorr, and Resnick, they attempted this type of supervised approach, and uh, another group of scientists, Swire and Stevenson, they used unsupervised approach, but always supervised approach will have more accuracy than the unsupervised approach. But the problem with supervised approach is we require manually annotated data, unfortunately, which is not available as per the requirement in NLP. So FrameNet, let us discuss supervised systems, then we'll go to other systems. First of all, let us discuss about the supervised systems. So FrameNet was the first successful supervised system used for semantic role labeling. Remember these two names, Gildia and Zuravsky. They modeled semantic role labeling as a supervised classification problem. They assumed that verb, predicate, and its arguments can be mapped to nodes in the syntax tree of a sentence. So, when we approach semantic role labeling, we come across three tasks. This was proposed by Gilday and Juravsky. They proposed that there are three important tasks. In fact, two important tasks. Then the third one is a combination of those two. The first task was argument identification, identifying all the phrases which are valid arguments of the predicate. We want to identify all and the phrases that represent valid argument. For example, Ravi ate rice in the morning. The relevant arguments are who ate Ravi, that is argument 0, what was eaten, rice, that is argument 1, and this is argument locational argument, adjunctive argument. If you remember in prop bank we have core arguments and then adjunctive arguments, and this is so identifying the arguments is the first task. Secondly, classifying them, assigning correct label to that argument. For example, in the previous sentence, the first Ravi is argument 0, rice is argument 1, which is the subject, and this is indicating the time, not location, time. So this is temporal argument, temporal argument. So two tasks in semantic role labeling which we have to do are, one is argument identification, another is argument classification. And we have to do both the things, then that is the third, argument identification and classification, combining these two tasks. So the process that will be followed is we get a parse tree, and once we get a parse tree, for example, if you see the parse tree, this is a parse tree. This is a syntax parse tree. So once we get this parse tree, then each node in that parse tree, for example, this is a node, this is a node, this is a node, each node will be classified into non-null mode, represents a semantic argument, and null node does not represent any semantic argument. For example, here in our example, this is not representing any semantic core argument. So if you see here null, it is not representing. Then the some are non-null. So non-null nodes are classified into set of argument labels which does not represent. Then we can see the semantic role labeling algorithm. You can mark it as an important question in the examination point of view, and this chapter, predicate argument structure, is extremely important. In this fourth unit, you have to focus on two questions. The first question is word sense disambiguation. The second question is predicate argument structure. These two questions, if you prepare thoroughly, you can certainly bag full marks for the fourth unit. Two, focus on two in the fourth unit. One is word sense disambiguation, another is predicate argument structure. So what is this algorithm? First, generate parse tree for a given sentence, full syntactic parse tree. That's what we learned in the syntactical parsing, second unit and third unit. Identify all the predicates. For each predicate, extract set of features for each node in the tree relative to the predicate. Once you extract them, classify. This is argument identification and this is argument classification. So classify each speech vector using the model created in the machine learning model created in the training. Then select the class label with the highest score. It may suggest the probability and you can adopt the label with highest probability. Then return the best semantic role labeling. So this is the semantic role labeling algorithm. Now let us see example here. Ravi ate rice in the morning. So parsing parsing will Ravi is the subject, ate is the verb, predicate, rice is the object, this is the time. So predicate, first one is predicate identification, ate is the predicate. Then extract features for each phrase, identification of features, argument identification, Ravi, rice in the morning. Classification, argument 0 is Ravi, argument 1 is rice, in the morning is temporal argument, and return the labeled structure. So this is semantic role labeling process. For that, we are looking into what systems can we use. In earlier class, we have seen the resources that we could use, and now we are talking about resources, systems. Resources, what we have seen, FrameNet and PropBank. And that is also very important question, the differences between the WordNet and the PropBank. What is the philosophy behind the FrameNet, and what is the philosophy behind PropBank? So we'll see syntactic representation, how we can use the syntactic representation. So we know that PropBank was developed on pen tree bank style. So this is the best examples that we have with PropBank tags. This is the syntactical tree. So now we'll see different types of grammars used in the supervised systems. So there we'll be talking about phrase structure grammar. You know, we have phrases, propositional phrase, verb phrase, noun phrase. These phrase structure grammar, how we can utilize in semantic role labeling supervised systems. So we'll discuss what are the different features that we'll be using. So there are almost all, if I remember, if I am not wrong, there are 36 features. This is also another important question. 36 features, at least you should be able to write minimum 15 to get 10 marks, and you can use one line or two line explanation for each of that feature. So these are not difficult, just we have to revise and practice. Number one, path. How the path of a constituent to the from the constituent to the predicate. For example, if you take our this 1. Argument 0 to predicate. First noun phrase, you have to go up, then sentence, then come down, then come down. This is represented as noun, go up, go to the sentence, come down, then the verb phrase, come down, then there is the verb. So this upward arrow indicates upward movement and downward arrow indicate downward. There is one path. What is the path between the constituent phrase and the predicate? Nextly, predicate itself is a feature that is used, the lemma of the predicate. You know the lemma, right? Lexical form of a given predicate, runs, lemma is run. Then phrase type, noun phrase, propositional phrase, sentence, and these can be used as feature. Then the position indicates whether the phrase appears before the predicate or after the predicate. For example, if you have a sentence, the cat chased the mouse, the cat appears before and mouse appears after the predicate, the chase. That position before or after the predicate, that can be used as feature. Then voice, whether it is active voice or passive voice. Active voice, the cat chased the mouse. Passive voice, the mouse was chased by the cat. That is a feature. Then you can use the head word as a feature. For example, you have the tall man. So what is the head word here? Generally, if there is sentence, predicate is the head word. And here, who is the head word? Man. And this is an adjective. Then another feature is subcategorization. How predicate's parent node expands. Verb phrase is expanded as verb and noun phrase. If you see our example, verb phrase is expanded as third person singular, verb VBZ, and noun phrase. This subcategorization is also used as the feature. Then verb clustering, grouping similar verbs, is also used as a feature, and something like verbs like eat, devour, consume, all are related to consuming the food. They can be clustered and that can be used as a feature. Then content word, the relevant word, if the head word is not informative. Here the head word is a feature, here the content word. For example, if you see the house near the river, here the house is the head word, but it is not giving any information where is the house. But here the river is the content word. That can also be used as a feature. Parts of speech, whether it is noun or a verb or whatever tag we can assign, that is a role. And suppose if I say this man, the organization is has run successfully, then the run is noun there, and he has run well, then that run is verb. So part of speech can be used as a feature. Then named entity of a content word, named entity. For example, what is a named entity? Time, place, organization, date. So Hyderabad is a place. That is a name entity. Then Boolean named entity flags. These are 8 flags, 7 flags are there. Person, place, time, date, money, percent, organization. These are Boolean named entity tags. These are also used as features. Then phrasal verb collocations, statistics of verb plus proposition combination. For example, give up, take off, climb up, get in. These are all phrasal verb collocations. Then logical function, it identifies if the argument is external object or the other. Here the cat chased the mouse, the cat is an external argument. Then order of frame elements, which order it is being arranged. So relative position of the arguments. Generally, if it is a direct voice or active voice, argument 0 will appear before the predicate and argument 1 will appear after the predicate. Then syntactic pattern, how noun phrase derives determinant and noun, that is the syntactic pattern. Previous role, knowing that the previous phrase was argument 0 or argument 1 will helps in identifying the next argument. Named entities in constituents, for example, temporal argument, locative arguments, they will help. Then verb sense information. Whenever a verb is there, it can give different meanings. For example, operate may give sense function, another sense is perform surgery. So if you use frame set ID, you can invoke the appropriate sense. So noun head of a propositional phrase. Here on the table, the noun head is table. First and last word, TOS. Ordinal constituent position, noun phrase 1, noun phrase 2. Constituent tree distance, measure distance between the constituent and the predicate. Constituent relative features, temporal keywords. So these are the different features that are used in the semantic role labeling when we are solving it with phrase structure grammar. Totally 36 features are there. So you have to write all of them in the examination.